This is for spiral review number 16. You should have numbers 1 through 5 done. Those should have been completed yesterday. So today you are doing numbers 6 through 11. This is just a little mini lesson on the concepts that you're going to need. All of this is from Unit 1. If you need to look back in your book, these concepts were pulled from Unit 1. So if you look at, these are just examples. These are not exactly like your problems. So you will complete the problems after this Ed puzzle. The volume of a cube, so V equals 512. And I know a cube, all the sides have the same measure. So this, and this are all going to be the same. What is the length of each side of the cube? Well, the formula to find the volume of a cube is the side to the third power. Since I know that the volume is 512, I'm going to pull out that V and I'm going to put in my 512. The inverse operation of cubing something is taking the cube root. 512 is a perfect cube, okay? If it was not a perfect cube, you could leave it in that format. But I know that the cube root of 512 is the same thing. I can multiply 8 3 times. So my side length is going to be 8. I don't need, and I could put inches. It is not inches cubes. It is just inches. Okay, so to find one of my side lengths, it's going to be 8, because then to get that volume, I would do 8 to the third power, or 8 times 8 times 8. My next problem deals with square roots, okay? Now, to take the square root of a number, I'm just going to figure out what two of the same numbers I can multiply together. Not every number is a perfect square, so not every time you're going to get a whole number, whole counting number. But 25 happens to be a perfect square. So since I know that 25 is a perfect square, I can think of what two numbers I can multiply together. So the square root of 25 is going to be 5. To check your work on a calculator, now you're not always going to have a calculator, right? But if you do have a calculator, you can hit that second key. And then you can hit the x squared. And then you would plug in 25, and then you would hit enter, and that should give you 5, okay? Now, the opposite of squaring something, well, not the opposite, but instead of squaring something, I can cube something. Okay, which is just going to be me taking that same number and multiplying it 3 times. Here is the problem. So to solve this equation, I would do the cube root of 37. Okay, the cube root of 37 is not a perfect cube. I can't do, if I do 2 times 2 times 2, I get 8. 3 times 3 times 3, I get 27. 4 times 4 times 4, I get 64. So 37 is not a perfect cube, okay? When I'm taking the cube root of a non-perfect cube, it is appropriate for me to just write it as the cube root of 37. So I know that x cubed is the same thing, this is the same thing as x cubed equals 37. They represent the same thing, okay? All right, exponents. Let's take a look at this first one. When you are raising a power to a power, you are going to multiply those exponents. This would simplify to be 4 to the 12th power. So when you have a power to a power, you are multiplying those exponents. When I am multiplying two expressions that have the same base, so these two numbers that have the same base, what's going to happen is that base is going to stay the same, and I'm not multiplying my exponents, I'm going to add my exponents. So it would be 4 to the 7th power. Dividing, it's like the opposite of multiplication. So instead of adding my exponents, I'm going to subtract them. My base is going to stay the same, and that would be 3 to the 9th power. Okay? Power to a power, you multiply. When you're multiplying bases that are the same, you add your exponents. When you are dividing bases that are the same, you subtract your exponents. Okay? Now, what I would do here is I would multiply my bases. Those are different, but I would keep my exponent. Okay? That's going to give you a large number, 20,736. But you can check. If you do 12 to the 4th, you get that, 20,736. And if you were to plug in 6 caret key 4 times 2 caret key 4, you would get the same number. My final example is when I have a negative exponent. A negative exponent does not mean that the number is negative. It actually means that the number is very, very, very small. So what's going to happen, numbers that are very small are decimals or fractions. So what I would do is I would take that and just put it under 1, okay? It's kind of like the reciprocal. So then this, you could simplify 3 to the 5th is the same thing as 1 over 243, which you see is a very small number. Okay, my next expression I need to evaluate. So I'm going to take 4, I'm going to rewrite this, times 4 to the 0, and then I'm going to take y and plug that in there. The first thing I do according to PEMDAS, order of operations, is I'm going to do my exponents. So I'm going to do 27 times 1, because 4 to the 0 power, anything to the 0 power is 1, times 1 over 3 squared. And actually, I'm just going to write that, getting rid of that exponent. So 3 squared is 9. Since it's all multiplication, I'm going to move left to right. 27 times 1 over 9, which is just the same thing as 27 over 9. This expression would simplify to be 3. So remember, whenever you have a negative exponent, change it into a fraction. Whenever you have a 0 exponent, that is always going to simplify to be 1. And then my final example is changing a number from standard notation, which this is written in standard notation, to scientific notation. So what I'm going to do, this is a very, very big number, so I'm going to have a positive exponent. And I know it's always going to be times 10 to some power. So what you're going to do is you're going to write in your decimal, which is back here, and I'm going to move my decimal to the left, so that way my number is greater than or equal to 1, but less than 10. While I move, I'm just going to count. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. That is going to represent my exponent. And then I need to write this number there. I don't need all of those zeros. You are not wrong, but you do need to make sure you have that decimal in the correct place. Now go ahead and do the 6 through 11 on your spiral review.